So I'm going to do this example, example 5. But again, for time consideration, after this, I'm going to move further in the lecture, but I will leave the problems in the notes, so you can go through them if you want, which I do recommend. You're also more than welcome to ask questions about them. So, okay. Actually, let me go through, not this one, let me go through this one, example 6. 5 is not that bad. Let me go through example 6 because this was one that it was a let them try, so I figured it was one I would let you try on your own. So let me go through this one. All right, so here, right, just like before, same idea, right? A is 1. B, as you can see, is 8. Right, the coefficient of x is b. C, the constant term is 4. Okay, so we have our a, b, c. And just like before, we have to get our vertex, right? I mean, generally the vertex you will have to find. Keep in mind here, well, actually, no, yeah, let me write this. We have y equals, before we had f of x equals, but it's understood to have this, y equals f of x, in the background. So I am calling the function here f of x, even though it's not written f of x equals. I could call the function g of x equals or whatever, but if you see something like this, in the background, you're going to have something like this. So we do have a function here. All right, so here, to get the vertex, we first have to get negative over 2 times a. All right, so what do we get here? We get negative 8, right? B is 8 over 2 times 1, which is negative 4. And again, to get the y coordinate, you have to plug this into the function. So we get negative 4 squared plus 8 times negative 4 plus 4, right? That's just direct calculation. That turns out to be 16 minus 32 plus 4, which is minus 12. So again, I'm just plugging it in, right? This is the x coordinate of the vertex. For this problem, we have this. Plug it into the function, we get the y coordinate. And so our vertex is actually this point. And the x coordinate, excuse me, the axis of symmetry, it's x equals the x coordinate of the vertex. So it's x equals negative 4. The range, right? Excuse me, since a is positive, a is 1, so we know the graph has to do something like this. I mean, is it going to do this exactly? I don't know. But it has to look something like this. It has to be pointing upward. The vertex then is at the bottom. Okay. And so the range would then go from minus 12, the y coordinate, up to infinity. And no, I didn't forget the y-intercept. It's on the next slide. Okay. So from here, right, we need the y and x-intercept. For the y-intercept, again, you just replace x by 0. In this case, you get 4. So that's what we get here. All right, good, good. Now you could try factoring this. I know it's tempting to factor it, right? Because the leading coefficient is 1. It's a trinomial. Degree is 2. Okay. However, you would need 2 numbers whose product is 4, but the sum is 8. Well, there are no 2 numbers that pull that off. So that's why I would use the quadratic formula. Okay. It doesn't mean there are no x-intercepts. It just means that you can't factor this. So it means that the x-intercepts, or the roots of this quadratic, they're not rational numbers or integers. All right. Anyway, so with the quadratic formula, we have this here. You know, we're plugging in a, b, and c. And when you do that, you get -8 plus or minus the square root of 48 over 2, right? But 48 is not a perfect square. I mean, you probably could simplify it, but I didn't do that. So we get -8 plus or minus the square root of 48 over 2. Okay. And so from here, right, we have two solutions, -8 plus the square root of 48 over 2, -8, and the other one is this, -8 minus the square root of 48 over 2. Good, good, good. Now this is good, as you can see. Get our two solutions. Again, these are only approximations. These are actually not rational numbers. So once we graph it, this is the graph we get. Okay. So we have this. Excuse me. Right? Our vertexes we found, -4, -12. The graph opens upward, right? You can see that. Here's our y-intercept. We got that also, the x-intercepts, and our vertex. So, all right. So that's what the graph looks like. Okay. Are there any questions about this one? Okay. Well, recall the standard form, right? You know, again, the standard form for a quadratic function is this. Now notice the minus here. It's x minus h squared plus k. That's actually very important. hk, remember, is the vertex. A is the same as before, ax squared and all that. Now, another purpose this serves us is the following. If we wanted to find an equation of a quadratic function, excuse me, let me say it this way. If we wanted to find a quadratic function, knowing its vertex and a point it passes through, we can do that. We can do that. Essentially, we know what the vertex is, so we know what h and k are. We know another point on the graph, right? So we can get the a here. Okay. So let's do some examples to illustrate that. Let's find a quadratic function whose vertex is 2, 0, and it passes through this point 1, 3. Okay, so what does 2, 0 tell us? Well, 2, 0 tells us, the vertex is 2, 0. That tells us this point 2, 0 is equal to the point hk. And when 2 points are equal, their coordinates are the same. In other words, the x coordinates are the same, so 2 equals h, which means h equals 2. The y coordinates are the same, so 0 equals k, that is k equals 0. All right? And so from here, right, we know what h and k are. So right away we know that f of x is a times x minus 2 squared plus 0, okay, which is a times x minus 2 squared. Just see something. All right, good. So we know that at least. Okay, now are we done? Well, no, we don't know what a is, but we do know something else. We do know that the 0.13 is on the graph of the quadratic function. And what that means is when x is 1, y is 3, the function is 3. That is, f of 1 is 3. F of 1 has to be 3. So, in other words, we must get 3 when x is 1. That's what this is saying. So we must get 3 when x is 1, right? So we have 3 equals f of 1, right? Which is a times 1 minus 2 squared, okay?